Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. My name is Ainur Amrabidusin with the student ID 2024554237. Today I will be presenting my final year project entitled Comparative Analysis of Heavy Metal in Dye and Non-Dye Sarawakian Hair using ICP-OES or Inductively Coupled Plasma Optical Emission Spectrometry. So, my video consists of 8 sections, starting with introduction, methodology, result and discussion, conclusion, limitation, recommendation, and references. Now, let me start with the background of this study. So, what is hair? Hair is a keratin-rich biological structure produced by hair follicle. It has become an important biological sample because it can accumulate heavy metal during hair growth. Compared with blood and urine, hair is a non-invasive, easy to collect and store, and reflect long-term exposure to heavy metals. Therefore, it is widely used in environmental monitoring and forensic investigations. Now, how about heavy metal? Heavy metals are naturally occurring elements with high atomic weight and density. Some metals, such as copper and chromium, are essential for normal body functions. However, others, including lead, cadmium, and excessive nickel, are toxic and may cause harmful health effects when accumulated in the blood. So, the problem statement for this study will hair dye product may alter the concentration of heavy metal in human hair because they can damage the hair cuticle and introduce metal-containing pigment. Although several studies have investigated heavy metals in hair, limited research has compared dye and non-dye hair among the Sarawakian population. Therefore, this study was conducted. So, this study has two main objectives. The first one was to quantify the concentration of selected 5 heavy metals, namely nickel, lead, cadmium, chromium, and copper, in both dye and non-dye Sarawakian hair using ICP-OES. The second objective was to compare heavy metal concentration between dye and non-dye hair as well as between male and female participants. This study is significant because it improves our understanding of how hair dye influence heavy metal accumulation. The findings also contribute to providing baseline data on heavy metal exposure among the Sarawak population, environmental biomonitoring, and support forensic investigation. Additionally, the study may contribute to public health awareness regarding the safe use of cosmetic hair products. As for the literature review, based on a study made by Fluoro, human hair is an effective biomarker because it accumulates heavy metal over time and reflects long-term exposure. Heavy metal enter hair through two main pathways based on a study made by Shukla at 2024. The first is internal deposition through the bloodstream after inhalation, ingestion, or dermal absorption. The second is external deposition from environmental sources such as dust, cigarette smoke, polluted air, and cosmetic products. Previous studies also reported that hair dye treatment changed the hair cuticle, increased hair porosity, and enhanced heavy metal absorption. As a result, dyed hair may contain higher concentration of heavy metal than non-dyed hair. Several environmental and lifestyle factors including smoking habit, occupation, diet, and cosmetic use, also influence heavy metal accumulation. Among the available analytical techniques, ICP-OES was selected because it allows simultaneous multi-element analysis with high sensitivity, good precision, and lower operating costs compared with ICP-MS. Finally, previous studies mainly investigated environmental exposure or cosmetic treated hair separately. Very limited studies have evaluated the combined effect of gender and hair dyeing among the Sarawak population, which formed the research gap of this study. For the research methodology, a total of 60 hair samples were collected from volunteers in Kota Samarahan, Sarawak. The samples were divided equally into 4 groups: male dye, male non-dye, female dye, and female non-dye hair. The hair sample were washed 3 times using 25 ml of acetone and 25 ml of deionized water to remove external contaminants before being air dried for 24 hours. Next, approximately 0.5 grams of each sample underwent microwave assisted acid digestion using 8 milliliters of nitric acid, and 3 milliliters of hydrogen peroxide. After filtration and dilution, the digested samples were analyzed using ICP-OES to determine the concentration of nickel, lead, cadmium, chromium, and copper. Finally, MANOVA was performed to determine whether hair type and gender significantly influence heavy metal concentration. Based on this study, as we can see for dye hair sample, male participants show higher concentration of nickel and lead than female participants. This may be related to greater occupational and environmental exposure, including industrial emission, cigarette smoke, and vesicle exhaust. In contrast, female dye hair contain higher concentration of cadmium, chromium, and copper. This is likely due to more frequent use of hair dye and cosmetic treatment among females. Previous study also reported that some hair dye contain copper pigment and chromium impurities, while repeated dyeing increased hair porosity, allowing greater metal absorption. Now, for the non-dye hair, females show higher concentration of nickel, lead, cadmium, and copper than male. Higher nickel concentration may be associated with daily exposure from cosmetic products and environmental sources. Copper may also be influenced by dietary intake such as seafood, rice, and leafy vegetables. However, chromium concentration was higher in male non-dye hair. This may be explained by occupational exposure, particularly among individuals working in construction, welding, metalworking, and automotive industries. The concentration obtained were then compared with recommended regulatory limits. The indicated permissible limit value were established by United States Environmental Protection Agency (USEPA) and World Health Organization (WHO) based on environmental matrices such as soil. A study made by Chang at 2023 stated that environmental reading and data can be paired with hair biomonitoring, which track long-term exposure to heavy metal, persistent organic pollutant, and other toxins absorbed into or onto the hair matrix over time. Overall, nickel, cadmium, and chromium concentration in all groups were within acceptable limits. However, lead concentration in male dye hair exceeds the recommended limit with a value of 0.144 ppm. Similarly, copper concentration in female dye hair exceeds the acceptable limit at 0.141 ppm. These findings suggest that hair dye products may contribute to increased lead and copper accumulation in hair. Last but not least, MANOVA analysis showed that hair type had a statistically significant effect on heavy metal concentration. The p-value was 0.002, which is less than 0.05, and the F-observed value was greater than the F-critical value. This indicates a significant difference between dye and non-dye hair. In contrast, gender showed no significant effect because the p-value was 0.473, which is greater than 0.05. Therefore, hair type has a stronger influence on a heavy metal accumulation than gender. In conclusion, this study successfully achieved the objective, which were to quantify the concentration of selected 5 heavy metals, namely nickel, lead, cadmium, chromium, and copper, in dye and non-dye Sarawakian hair sample using ICP-OES, besides to compare heavy metal concentration in both female and male participants. Among the analyzed metals, copper recorded the highest overall mean concentration, while cadmium showed the lowest. Dye hair generally contain higher concentration of heavy metal than non-dye hair. Most metal concentrations were within permissible limit, except for lead in male dye hair and copper in female dye hair. Overall, this study suggests that hair dye treatment may increase heavy metal accumulation and provide valuable baseline data for environmental monitoring and forensic investigation in Sarawak. Actually, there are several limitations in this study. First, the sample size was relatively small, with only 60 participants from Kota Samarahan, so the finding may not represent the entire Sarawak population. Second, only 5 heavy metals were analyzed, while other important metals such as arsenic, mercury, and manganese were not included. In addition, participant information such as occupation, diet, smoking habit, and hair dye history was limited, which may have influenced heavy metal accumulation. External contamination from dust, air, or cosmetic may also remain on the hair despite the washing process. Lastly, ICP-OES measure only the total metal concentration and cannot determine the chemical form of the metal, which are important for evaluating their toxicity. For future studies, I would like to recommend increase the sample size and including participants from different regions of Sarawak and other states in Malaysia to improve the representativeness of the finding. Additional participant information such as smoking habit, occupation, diet, and hair dye history should also be collected to better identify factors influencing heavy metal accumulation. Future research should analyze more heavy metal and use additional biological samples such as blood or urine for a more comprehensive exposure assessment. Advanced techniques such as ICP-MS or LA-ICP-MS could also be used to improve analytical sensitivity. Finally, commercial hair dye products sold in Malaysia should be analyzed to identify possible sources of heavy metal contamination. These are the references that I have used. That concludes my presentation. Thank you very much for your attention. Bye!